Hey, it's Mr. A. First of all, congratulations on being in the Mastery Plus group this week. You totally crushed Powers of 10. Now, we're going to take a look at a 6th grade standard that kind of brings in Powers of 10. Still works on whole numbers, not quite as much decimals, but it's all about factors, multiples, and prime factorization. It's essentially listing out all of your math facts and organizing them. That's pretty much all this is. So you're going to have these papers with you, and I would like for you to follow along. So anything that I write down, I would ask that you write down too. Make sure that your name is up at the top of these papers, and then we're going to go ahead and get started. So first, it talks about Nancy, and she has 10 movie posters, and she wants to hang them all on a wall in equal rows. Find all the ways that she can arrange the posters. So if we see here, she has a 1 by 10. Here she has a 2 by 5. Here she has a 5 by 2. And here she has a 10 by 1. So these are all of what we would call the factor pairs that you can represent with 10. Nothing else can multiply to 10 except for 2 and 5 and 1 and 10. That's it. Whole number wise, those are the factor pairs. So let's take a look at these questions. Number 1 says the equation 1 times 10 equals 10 represents the first way that Nancy can arrange her posters. Write 3 more equations. Well, first of all, underline that word equations and put an equal sign right beside it. We must have an equal sign anytime we write an equation. Well, if we look at the second one up here, we can see that it's 2 by 5, and that equals 10. The third one over here is just the order flipped, because order of multiplication does not matter. And then the last one, number 4, we see that it's also just flipped, so we can see that it's a 10 times 1 is equal to 10. They all equal 10. So what are the factors? Here's how we write these factors. You use commas. You always start with the smallest and the biggest number on the two ends. So we know 1 times 10, 1 is the smallest factor, 10 is the biggest. And then you put any other factors in the middle in order from least to greatest. So 2 and 5 make 10. Write 2 factor pairs of 10. Well, we know that we have 1 and 10, and we know that we have 2 and 5. And it says, what do the factor pairs represent in this situation? Well, it represents number of rows and columns that she's organizing those posters. So how would the factor pairs change if Nancy had only 5 posters to arrange? Well, if we think the only numbers that multiply to 5 are 1 and 5, and we could flip the order around and put 5 times 1. That's it. 5 is an odd number, and nothing else multiplies to 5. That's a whole number, 1 and 5. So these words over here are super important for vocabulary. So if you will star these words, all 3 of these are words that we're going to need to know this week. A factor is any number you multiply. A factor pair are those 2 numbers together. And then a multiple is essentially a skip count. So anytime that you are trying to ask and figuring out what the multiples are, you're just making skip counts. Perfect. Hopefully you're following along so far. Let's take a look at the second page. So number 6 is talking about the factors of 24. Well, anytime I'm asked about factors, I like to list them all out. So let's start. We know 1 and 24 are the biggest and the smallest. 24 is an even number, so I know that 2 has to go in, and 2 times 12 is 24. 3, my next smallest number, also goes in because 3 times 8 is 24, and 4 goes into 24 6 times. And the only number that I'm missing in between here is a 5, but I know that 5 cannot count to 24. So these are my factors of 24. So letter A, an arrangement of 24 objects could be 4 equal rows of 6. Yeah, 4 times 6 is 24. 2 and 12 are factor pairs? Yes, because 2 times 12 is 24. 24 is not a factor because a number cannot be a factor of itself. False. Yes, it can. 24 times 1. Anything times itself and 1 always work. All of the factors are 1, 2, 6, 12, and 24. Well, if we look, this keyword all here, and we look up at our list, I see, 3 and 8 are also factors in there. So this would also be false. Mina baked 50 muffins. She is arranging the muffins on plates. She wants the same number of muffins on each plate. Complete the table to show the different ways that Mina can arrange all 50 of her muffins. So if we think here, what are all the factors of 50? All right, well, I know that one, she could have one big plate and put all 50 muffins on there. She could have 2 plates because 2 goes into 50 25 times. 3, I can't count by 3s to get to 50. 4s, I can't count by 4s either because 4 does go into 5 one time, but then 4 doesn't go into the 10 left over. But I know that 5 can go in there. It goes in 10 times. If I think 6, nope, not 6. 7, not 7. 8, not 8. And 9 doesn't go in either. So essentially, all the ways she can do it, she could also have 50 plates and put 1 muffin on each. That's a lot of dishes. She could put 25 plates out with 2 muffins on each, or she could put 10 plates with 5. I think that one makes the most sense. So what are all the factor pairs? We have 1 and 50. We have 2 and 25, and we have 5 and 10. All right, we have a couple more problems here, and then you're going to try some on your own. Jill arranged all of her baseball cards in 4 rows of 9 cards. Then she arranged the cards in 2 rows of 18. How many other ways can Jill arrange all of her cards? Well, first of all, I need to figure out how many cards she has. 4 times 9 is 36. 18 times 2 is 36. So I'm looking for how many different pairs, what are my factor pairs of 36? So I know 1 and 36 are my biggest and smallest. 2, as it listed there, and 18 go into 36. 3 and 12 go into 36. 4 and 9 go into 36. And also 6 goes into 36. Okay, these are a lot of factor pairs. So the question asks, how many other ways can she arrange her cards? Well, she did 4 and 9, 4 rows of 9 cards, 2 rows of 18 cards. So then she could also do 9 rows of 4 cards, and she could do 18 rows of 2 cards. Okay, so there's 2 more ways. And then we got to think, okay, well, she could do 1 and 36, or 36 and 1, so there's another 2 more ways. We already did 2 and 18. We checked those off. We haven't done 3 and 12 yet, so there's another 2 ways because it could be 3 rows of 12 or 12 rows of 3. We already did 4 and 9, and then we have 6. Well, since 6 is times itself, 6 times 6, that's only 1 more way. So how many more ways can Jill arrange her cards? 2, 4, 6. She can do 7 more ways, 9 total. All right, last one. Look at problem 8. Sam has fewer baseball cards than Jill. There are only 3 ways that he can arrange all of his cards in equal rows. Write all the possible numbers of baseball cards that Sam could have. So we know that he has fewer than 36. And we also know that there are only 3 ways that he can arrange his cards. This is a very interesting clue. He has fewer cards than Jill. So our number has to be less than 36. And there's only 3 ways. So that would mean that it's 1 by itself, whatever that number is, and then something times itself here. Like 6 times 6 was only 1 way. So if we think, it could be that he has 25 cards because 5 times 5 is 25. And this would mean that he can only arrange it 3 ways. If we did 1 and 4, that would mean that he can only arrange them in 3 ways because 4 times 4 is 16, and 1 and 16 are the factor pairs. Oh, but 16 is an even number, Mr. A, so we could also have 2 and 8 in there. So this one does not work. So you don't have to write that one down. So far we have the 5. What about 1, 3, and 9? 1, 3, and 9. 3 times 3 is 9. 9 times 1, that one works because it's an odd number. Those even numbers trip us up. Could it be 4? 1, 2, and 4. 4 is an even number, but 2 times 2 is 4, and 4 times 1 is 4, and that only creates 3 ways as well. So all the possible numbers of baseball cards that he could have. So our final answer, he could have 4 cards, 9 cards, or 25 cards? That's what we're looking for. All right, you have these next 2 pages. I want to see if you can figure out how to solve these problems all by yourself. So what I'm going to have you do is I'm going to have you pause the video. I want you to read through this paper, and then I want you to try to answer these 3 questions. After you've answered these 3 questions, play the video, and then look to see if your answers represent my answers. Good luck. So number 1, you should have written, what does the greatest common factor represent in the situation? Well, we're talking about red balloons and blue balloons. The common factor are the number of bunches. The greatest number of balloon bunches that Alice can make is 3. So what does the greatest common factor represent? What does that 3 represent? That would be the greatest number of bunches, or something close to that. Number 2, Alice decides to use all of the balloons to make 3 balloon bunches. How many red balloons and how many blue balloons are in each bunch? Well, if she decides to use all of the balloons to make 3 balloon bunches, how many red balloons and how many blue balloons are in each? Well, if she has 6 balloons, we can see that there are 2 red in each. And if she has 15 of the blues with 3 bunches, there are 5 balloons in each. So how many reds and how many blues are in each? 2 red and 5 blue in each. Last one. Alice makes 2 bunches of balloons. There are the same number of reds and the same number of balloons. Did she use all of them? Well, if she uses 2, there'd be 3 reds in each. Ooh, but blue doesn't have a factor of 2. So did she use all of the balloons? No. Some blue left over because 15 is not an even number. Hopefully you got all 3 of those correct. All right. So now that we're on this page, least common multiple, you're basically making a skip count of those 2 numbers. So we can see here that Miriam is buying plates and cups for a party. Wants the same number of each. Plates are sold in packs of 8, cups are sold in packs of 24. What's the least number that he can buy? Try to answer all 4 of these questions on your own as the video pauses without moving forward all by yourself. Then when you think you've got it, go ahead and unpause the video and we'll walk through them together. So here we go. Number 1, John says that this means that Miriam needs to buy 24 packs of plates and 24 packs of cups. Is John correct? John, that would be a very expensive order, you silly goose. No, because if we look at the 8, the plates over here are represented by the 8 and the cups are represented by 12. He only needs 3 packs of plates and 2 packs of 12, not 24. Holy moly, guacamole. No. 24 is the number of plates and cups that he needs, not how many packs he needs. Number 2, what is the least number of packs of plates and cups that he can buy? Well, how many 8s does it take to get to 24? 3 packs of plates. And how many 12s does it take to get to 24? 2 packs of cups. That's the least number of each. Name 3 other common multiples of 8 and 24. Well, hopefully you were paying attention to the list and the skip count up here. I see that 48 is a common multiple of each of those. And I also see that 72 is a common multiple of each of those. So I know that 48, I know that 72, and then I don't quite have another number listed, so I could keep going. So 72 plus 8 is 80. Then I would have 88, and then I would have 96. I can see that that's where my next skip count comes similarly. Could Miriam buy exactly 40 plates and 40 cups? No, Miriam, silly, silly goose. These people are not counting very correctly. 8 does go into 40, but however, 12 does not go into 40. So 12... actually, let's reword that here. Let's say that 40 isn't a multiple of 12. Hopefully you did well. Hopefully this is making sense. Guys, essentially all we're doing here are making skip counts and figuring out your math facts. That's all this is. It just sometimes takes a little bit of work to list out all of those pairs. and to really understand what in the world these questions are asking. So, British Mr. A is super proud of you. Hopefully you've got all of this written down and you're ready to turn it in this Friday when we turn in all of our checklist items. Please make sure everything is filled out. I am so proud of you, and good luck on your next task.